let's get started. Oh, did you say something?
What's that hi?
You said hello? Oh, okay. It's like, oh, Javon, I didn't know you were here. Hello. All right, so today, nothing crazy. We're going to talk about lines again. Equation of lines. We're then going to again review functions again. Like I said, the first half of this class is really just going over a lot of things you went over in algebra. But we just kind of want to make sure that you know these things super, super well. So we are going to once again revisit lines. So this is 1.10, I think. Lines. So let's actually begin. Lines are curved with constant steepness. So something like this, for example, that is called a line whenever you see that sort of guy. And so now to measure steepness, what do we mean by how steep something is? It's usually a relative kind of measure. We use the ratio rise over run from some fixed point. And so if you have, for example, the run is the horizontal distance covered, the rise would be the vertical distance covered, right? And so we can measure the steepness of this guy is given by the ratio of this. Let's say that's rise 1, run 1. So it's just some numerical measurement of how steep something is, and really it's relational. So from some fixed point, you can have a long run and a small rise, and you would end up with something like that. And so the steepness here is equal to rise 2 over run 2. And we would take the convention that this is more steep than that. Okay? So because since the first ratio is larger than the second, so we talk about a curve of constant steepness, meaning if you're measuring the run versus the rise from any fixed point, it'll always be the same. So I can measure rise versus run like that. I can measure rise versus run like that, and the ratio will always be the same. So we come up with this idea of steepness. What does it mean to be steep? Well, steep from one thing compared to another, just comparing this ratio. The higher the ratio, the more steep the thing is. Okay? So now we want to actually put some numerical values to this. And again, we can use the Cartesian axis to do that. All right, so what you can do is suppose the line passes points x1, y1, and x2, y2, we will be able to set up the graph here. Then we can set up this sort of picture here, where this, let's say that's the first point, x1, y1. This is the second point, x2, y2. Notice by what we know about the Cartesian axis, that would mean the point vertically below this would be x1, point vertically below this would be x2, the point horizontally across from this would be y1, the point horizontally across this would be y2. And so what we have is this sort of measurement here. So we have here is what we would define as the run. Now you notice that the run is just a horizontal distance. We know how to measure that. Take the right point minus the left point. So we get x2 minus x1. And over here, we have what's called the rise. Now if you wanted to measure that quantity, these are the two numbers that you use as reference point. The distance here is going to be this minus that. Therefore, we can come up with a convention thus the steepness of this line is rise over run equals y2 minus y1 over x2 minus x1. And we call this ratio the slope of the line. Now, I don't know the history behind why it's called slope, but that's what we call it. We call it the slope of a line, and typically note it by m. This means m equals y2 minus y1 over x2 minus x1 is the formula for the slope of a line that passes through 2 points, x1, y1, and x2, y2. That's our first formula. Okay. So we come up with a curve that has constant steepness, where steepness is measured as the ratio of how high it rises versus how long it's horizontally running. Throwing these on the Cartesian axis allow us to come up with a very nice formula for such a curve. Now, we want the equation of such a curve. Right? How do we find arbitrary points on such a curve? We kind of set it up the same way. So suppose it passes through x1, y1. And what we're going to do is let this point here be a variable. We're going to imagine that we can slide this point along anywhere along this line. So at any point along this line, we can talk about the points that fit an equation. And so let's call this x comma y, right? So not a fixed point, not two, right? We're letting x comma y vary, right? This can vary. And thus we can say m would be y minus y1 over x minus x1, right? Because the slope is constant. Anytime I take a ratio, no matter what that point is, the answer will be m. And then I can actually multiply both sides by x minus x1 and we get y minus y1 equals m x minus x1. This is a very important formula. It is the equation of a line. It is one of several versions. This is called the point slope form. Of the equation of a line. And you can note all xy that satisfy this equation are on the line. Okay. So this is how you find the equation of a line. Arbitrary values of x and y that fit this equation, those are literally points on the line that you can plot. Okay? Your y1 and your x1 is just some reference point, some fixed point, right? Just take your bearings from that point, and now we can describe any other point running along the line via this equation. This gives us the equation of the line. And because I used a fixed point and the slope to come up with this equation, it's called the point slope form. And it's useful when, it's useful in this particular situation. Useful when you know a point and the slope. So if you ever need to find the equation of a line and the information you have is a point on the line and the slope of the line, you can use those two pieces of information to find the equation of the line. Now, last time we spoke about intercepts, and we know that finding intercepts was a very important thing to be able to find. So sometimes it's nice to describe equations in terms of their intercepts. Suppose we make the reference point the y-intercept. This means take the x1 comma y1, that reference point, and set it equal to something that looks like that. We know anything that's on the y-axis has that form as a coordinate. The x-coordinate will be 0, and b is just going to be some constant. Namely, the b is going to be the guide where your line touches the y-axis. Now, if I let that be my reference point, I can plug that into this equation. Y minus y1 would be b, and x minus x1 would be 0. So I get y minus b equals mx, or I get y equals mx plus b. This is another form of the equation of a line. It is called the slope-intercept form. And this guy is useful when you have those two pieces of information. If you know the slope and the y-intercept, you can actually use those two values to find the equation of the line. So those are two very important equations for a line. In general, either writing the equation of a line in either of these forms is going to be fine unless a problem I give you specifically asks for one of them. Let's mention something else. Another note. given 2 points on a line, we can find the slope using m equals y2 minus y1 over x2 minus x1, and then use either of the above boxed equations to find the equation below. So we have the equation that gives the slope, which is this guy. We know the point slope form, which is y minus y1 equals mx minus x1. And we know the slope interform, which is y equals mx plus b. It's very important that you realize that in these equations, your x and y remain x and y. They need to allow to be variables. But your m and your b will be constants. Your x1 and your y1 are also assumed to be constants at any given time. Meaning, if you plug in a variable for either of these values, then it is more than likely not a line. Again, you probably won't encounter a situation where that will happen here, but you'll encounter it in calculus all the time. So, just last week I had students, I asked them to find a tangent line. Don't worry about what that means. But anyway, they got a formula for m in terms of x, and then they plugged it in here and got an x squared. The moment you do that, and don't make sure this is a constant, it's not a line anymore. It has to be in this form. It has to be a constant times x plus a constant. Otherwise, it's not a line. Lines have these forms. Occasionally, there might be another form that you see a line in. Can't have both of these be 0, not both 0. Surprisingly, this is called the standard form for the equation of a line, but people hardly actually use it. A lot of times it will be given to you, and you kind of want to convert it to one of these other forms anyway, but it's a bona fide form for the equation of a line. You pretty much get it by just moving the x's and y's to one side, and then just maybe multiplying through to kill fractions or anything like that. And you can get to this form of the equation of the line. It's standard because it's nice to work in this form in some contexts, but not in pre-calc or calc 1 usually. It's usually something higher. You want to think of a line in this way. So, basic formulas to describe such a curve. And where are we? Okay, let's talk about two special kinds of lines. Over here. Talk about vertical and horizontal lines. We'll get to some examples soon. I'm just trying to lay the groundwork and tell you about the formulas that we're going to be using, and then we'll go through some examples. A horizontal line is defined as one that has slope 0, i.e. m equals 0, and we get the equation y equals b. So anything that looks like y equals a number, this b is a constant, that is a horizontal line. So you can see y equals 5, y equals 7, y equals pi, y equals 3.9. Doesn't matter. Y equals any number is a straight line, and it is a horizontal line. Does not matter what the number is, as long as you have y equals a number, it is always a horizontal line. Because you pretty much go into that formula I just gave you and plug in m equals 0. Also note, m equals 0 means there is 0 rise for any run, i.e. the graph of such a line I'm going to give you an illustration. It's going to be something like this. It's just going to be a line with 0 steepness. It will be parallel. I didn't describe what parallel means yet. It will be parallel to the x-axis, and it will pass through the point here, B. And your B can be anything. It can be below the x-axis or above, but it will always maintain the same distance from the x-axis. And so no matter how much you run, there's no rise. You're just running with no rise. A vertical line has an undefined slope. Some might think of this as an infinite slope, but probably not true. From the picture, it might be nice to think of it that way, but you probably don't want to think of it that way in general. Pretty much because the slope is a ratio, it's only undefined if the denominator equals 0, right? So we know about fractions if a denominator is 0. And so what you kind of have is this situation. So at some point, it's like you're not running, you're not moving horizontally at all, but there is some rise. So you can have rises, but no runs. And you end up with a line that looks like that. And what you would notice, it will pass through somewhere here. Let's call that value k. And what you'll notice that along this line, all the coordinates look like k, comma, y. The x-coordinate will always be k everywhere along this line. And that kind of tells us how to write the equation of a vertical line. It does not have the same form as a regular line. Some constant. So x equals any number is the equation of a vertical line. Simply pick that line on the x-axis and draw a vertical line through. So both horizontal lines, these are the kinds of lines where you can draw them with one point, right? If I tell you any one point and I tell you this is horizontal, you can figure out the equation, right? Because every point along here is going to look like x comma b. So if I give you a random point and say, okay, here's a point on the horizontal line, here's a point on a horizontal line, all you need to do is make the y-intercept that coordinate and just draw it like that. Right? You only need one point to draw a horizontal line. And also, you'll need one point to draw a vertical line, right? Because the x-coordinate will always be the same anytime I give you a point and say it lies on a vertical line, just plot that point on the x-axis and run a vertical line through. Right? But you're drawing a horizontal or a vertical line. You do not need more than one point. If you're plotting more than one point to draw such a line, you are wasting time. Okay. What else do I want to mention? Okay, the sign of the slope. Let's illustrate this. Suppose you have a line that behaves like this. Let's say it goes through the point 1, 1, and it also goes through the point 3, 5. Basically, this is an example of a line where as the x-coordinate gets larger, the y-coordinate gets larger. What you'll notice with such a line is that here, in this case, you would have n equals y2 minus y1 over x2 minus x1. In this case, you would get 4 over 1, and turns out that it's positive. It turns out that it will always be positive in such a case. Because you always have a positive value for the run, because you're always taking a larger number minus a smaller one. You'll also have a positive number for the, you have a positive number for the rise, you'd also have a positive number for the run, because they both get larger together. And so this point minus that point will always return a positive number. So the slope will always be positive in this case. Conversely, if as x gets larger, y gets smaller, as in, and let me give you a random example. Let's say over here we are 1, 5, while over here the x is some larger number, like say 4, but the y value is all obviously a smaller number. This, then notice here the rise will be a negative number while the run is a positive number. So n would be less than 0 in general. Here specifically, m would be y2 minus y1 over x2 minus x1. So I get minus 4 over 3. But this pattern happens in general once you have this sort of behavior. If as your x gets larger, your y gets larger, you end up with something where the m will always be positive. If as your x gets larger, your y gets smaller, you'll end up with a situation where your m is always negative. And this leads us to pretty much all the situations we can be in for a straight line in terms of its graph. You can have one situation. This is where your line goes up as you move from left to right. This defines a situation where the slope is positive. Such a line is called increasing. So I can tell you this line is increasing. It's the same as me telling you it's positive slope. It's the same as me telling you it moves up as you go from left to right. You can have a situation like this. In this case, the slope will be negative. We say this line is decreasing. Okay. So if I tell you a line is decreasing, it's the same as me telling you the slope is negative, which is the same as me telling you as you move from left to right, the line goes down. We have this situation. Here, as discovered last time, the slope is 0. This line is called constant or horizontal. It means it's always flat. There's no rise. It doesn't tilt up or down. It just remains flat and with a 0 slope. And the last situation is this situation. Here, M is undefined. And such a line is called vertical. So these phrases refer to specific kinds of lines. So if I tell you, oh, we have an increasing line, or we have a decreasing line, or we have a constant line, or we have a vertical line, I'm describing one of these situations. What is the next thing I want to tell you about? Parallel versus perpendicular. Definition. Two lines are called parallel if they have the same steepness, i.e., the slopes are the same. i.e., if L1 and L2 are lines with slopes M1, M2 respectively, then L1 and L2 are parallel if and only if M1 equals M2. That's an important distinction here. I can look at the equation of two lines and I can know that they are parallel if their slopes are actually the same. So it could be like this and that. They'll actually never meet. So once they don't meet, they will never meet. Or so this could be L1 and L2. So if they have any point not in common, then they have all points not in common. That would be parallel. Another situation is you have two lines right on top of each other. So the moment two parallel lines share a coordinate, they actually share all coordinates. So those are really kind of two situations for parallel lines. Perpendicular lines are a little bit more sketchy, especially trying to get to an equation for their slopes. That's kind of tough definition. Two lines are called perpendicular. If they intersect at it's called a right angle. that means 90 degrees. Or this in the case that they're non-vertical. If one is vertical, then the other must be horizontal. So a perpendicular line is described in kind of in two parts. So one, if they meet at right angles, this is in the case where they are non-vertical. Or two, if you know one is vertical, then the other must be horizontal. So any vertical line is perpendicular to any horizontal line, vice versa. Otherwise, we define perpendicular by that they meet at right angles. Now, why did I single this one out? Well, I ultimately want to come up with an equation that describes the slopes, but we know that the vertical lines don't have slopes, so the equation wouldn't make sense in this case, so I decided to split it off. But otherwise here,
what did you write there? You put M1
Respectively.
yeah, respectively, RESP dot, short for respectively. So here's the question. What's the relationship between N1 and N2? In the non-vertical case. Well, let's figure it out. Okay, yeah. I think this is the last theoretical thing I'm going to talk about, then we're going to do some examples. I just like when you guys appreciate that the things I'm telling you, they come from somewhere. You know, it's like, not I put, oh, we just randomly made these things up. It was deductive, one thought led to another, and we came up with all these rules. So how are we going to figure out how these slopes relate? So let L1 and L2 be non-vertical, perpendicular lines. And in order for you to understand the idea, what I'm going to do, we're going to translate them. Translate just means shift them around so that they both meet at the origin. Okay, so let's say the origin is over here. Let me draw that a little bigger. So we know the origin is over here. So let's say I know two lines are over here. They meet at right angles. What I'm going to do is I'm going to take this entire picture and shift it so that this point lies on top of the origin, right? By me just shifting everything all at once, I maintain the angles. They're still perpendicular, right? So I'm just going to shift this point to be here. And so now what I'll have is I'll have the one line doing like this. Let's call that L1. And I'll have the other line doing like this. Let's call that L2. Now, I can think of their equations in this form. let's use y equals mx plus b. Here, clearly the b would be 0 for each line. So I can just say this one is just going to be y equals m1x plus, of course, 0. This one is going to be y equals m2x plus 0. Let's distinguish the y, call this y1, call that y2. So these are the equations of the two lines now, after being shifted. So now, here's what we're going to do. Pick the point 1 on the x-axis. Right? You'll see why I pick the point 1 soon. So, and I'm going to look at these two coordinates here. Now, if the x is 1, what is going to be that coordinate? And the x is 1, what is going to be that coordinate? What's the coordinate here? No. Remember, that's my equation. So if x is 1, what is the y? m1. Similarly here, if my x is 1, the y coordinate is m2. Right? I picked 1 so that the y coordinate is just the value of the slope. That's why I picked 1. Okay. So that will be this situation. Okay? So now I'm going to try to figure out, okay, can I find a relationship between these two y coordinates? Right? That's my idea. Now I know this is a right angle here, and let's label something so I can write down the ideas easier. Let's call the origin O. Let's call this point A. Let's call that point B. Okay. Notice I can even do this. You'll see why here. Okay, so now let's start to look at some magnitudes. Okay. What is going to be the length of this OA? How would I figure out that length? How do you think OA is going to look? How can I figure out this length here? Yeah?
Is it distance formula or something?
I can't hear you.
Distance formula? Or
The distance formula? Yeah, I could use the distance formula. Yeah, I was going to say, oh, you could look at this as a right triangle, but yeah, we actually have the coordinate,
okay.
so we can just use.
I see.
Technically, we use Pythagoras' theorem to derive the distance formula. So either way, you could say, oh, there's a right triangle here, let's use Pythagoras' theorem, but yeah, that would look at like the distance formula. So here, distance formula says, the length of OA is going to be, what would the distance formula say here? x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root, right? That's the distance formula. Because this coordinate is 0, 0. So it's 1 minus 0 squared plus m1 minus 0 squared, and then you take the square root. Also, if I look at OB, right, this distance here, I can again use the distance formula to figure out that length. x2 minus x1 squared is just 1 squared, plus y2 minus y1 squared, that's just m2 squared. And take the square root. Also, you're going to see what I'm going to do soon. What would be the length of AB? Same idea, right? Say x2 minus x1. That's 1 minus minus 1 squared plus, it doesn't matter which way I go, let y2 minus y1 right? So this just becomes
M1 minus M2 squared.
m1 minus m2 squared. So at this point, some of you are probably wondering where I'm going with this, but your patience is about to pay off. We're about to wrap up here, right? So I shift the lines to the origin, create these coordinates where the x-coordinate is 1, so I can find the y-coordinates very easily. We can use distance formula to find all these lengths. But now, look at the triangle OAB. That's a right triangle because they're perpendicular. Now we can apply Pythagoras' theorem. Which means I'd be able to say the square of the hypotenuse is equal to the sum of the squares of the other two sides. I'd be able to say AB squared is equal to OA squared plus OB squared. Now if I square that, I would get m1 minus m2. If I square this, I would get 1 plus m1 squared, plus if I square that, I would get 1 plus m2 squared. Right? So this equation must hold by Pythagoras' theorem. Now, that's been on so many quizzes by now, so we know what that becomes. It's m1 squared minus 2 m1 m2 plus m2 squared. This is 1 plus 1, that's 2 plus m1 squared plus m2 squared. At this point, let's start to clean things up a bit. We can subtract things from both sides. Subtract m1 squared from both sides, subtract m2 squared from both sides, and divide both sides by 2. And what do we have? Or let's look at it another way. Let's divide both sides by negative 2. That means your m1 times the m2 is going to be what?
-1.
Negative 1. That's the relationship between the slopes of perpendicular lines. In other words, one is always the negative reciprocal of the other. This leads to a theorem. L1, L2 are perpendicular with slopes M1, M2 respectively, then M1 times M2 is always going to be minus 1 if they are not non-vertical. So for perpendicular lines, the product of their slopes is minus 1. And another way to express this is that one slope is always the negative reciprocal of the other one. In other words, M1 you'd be able to say is minus 1 over M2, and M2 is minus 1 over M1. Slopes are negative reciprocals of each other. And I never have to worry about dividing by 0 because they're non-vertical, which means the other one is not horizontal, so the slope is never 0. So you can also remember it now for non-vertical perpendicular lines. At that point, you know everything there is to know about a line. Let's have to sketch it, but we can figure that out now. We're going to do a lot of examples. So now we know lines. We know the slope formula for a line. This describes the steepness of the line. This is y2 minus y1 over x2 minus x1 equals to the slope when the coordinates are x1, y1. We know about the point slope form of the equation of a line, y minus y1 equals mx minus x1. We know about the slope-intercept form of the equation of a line, y equals mx plus b. And we know that parallel lines have the same slope. Perpendicular lines have the product of their slopes is -1 as long as they're non-vertical. And in the vertical case, any other horizontal line is going to be perpendicular. Okay. So let's do some examples. So suppose I know a line passes through 2 points, -1, 2, and 3, 4. Find the equation of such a line. 2. Find the equation of the line that passes through the point -2, 3. And A has slope 2. B is horizontal. C is vertical. D is perpendicular, or let's do parallel first, is parallel to 2x plus 3y equals 7. E is perpendicular to 2x plus 3y equals 7. So these are 4 separate situations, right? So one question is find the line through this point that has slope 2, then reset, find a line through this point that's horizontal, reset, find a line through this point that is vertical, find a line through this point that is parallel to this, find a line to that point that's perpendicular to this. So all in all, there's 6 examples here. Okay, how do I do 1?
First find the slope.
Sure, how do I do that?
4 minus 2 over 3 minus -1.
So x1, y1 equals -1 to 2, and x2, y2 equals 3, 4. It doesn't matter who you call who, the ratio is going to work out the same. So now your slope will be y2 minus y1 over x2 minus x1, as you said. So that would be what?
1/2.
Right, that would be 1/2, 2 over 4. And so how do we get to the line now?
Slope at one of the points into the point intercept slope. 4.
I like to use the point slope form. Can use that?
Yeah.
We would get y minus 2 equals m x minus a minus 1, which that's fine as far as I'm concerned. You don't have to do anything else at that point. But if you are asked to find the slope-intercept form, you just solve for y. That would be 1/2 x plus 1/2 plus 2. In which case you can write it as y equals 1/2 x. 2 is 4 over 2 plus 1 over 2, 5 over 2. Yeah, so that's the equation of the line. The line that goes through those 2 points is that guy, or this guy. A. Okay, how would I do part A? I choose the slope again. Y minus y1 equals x minus x1. And just plug in the points. I know that my y1 is 3. My m was given as 2. And my x1 is minus 2. So that's going to be the line. And in general, that would be fine for me. I wouldn't care. Or if you want to put it in the slope-intercept form, you can solve for y. 2x plus 4 plus the 3 that you bring over. So you know y will be 2x plus 7. What about b? Y equals 3. Nothing else to do, right? It's horizontal. We know it has to be y equals a constant. And since we know that the y goes through 3 at this point, it'll always go through 3. There's nothing else to say. C. Vertical.
X equals
X equals minus 2. D. So I know it passes through this point. It is parallel to that. How do I figure that out? I would plug in -2 and 3 into that. Why? What do we do now?
We change that to y equals mx plus b, and then,
You want to rewrite this?
yeah, and
Okay, so if 2x plus 3y equals 7, this means, how would you rewrite that?
so 3y equals negative 2x plus 7, and then divide by 3.
And then what?
I'm not sure. You have your slope now, so then,
Then what? Oh, you're speaking very low.
yeah, I'm not sure yet. Just give me a second.
You're not sure at this point? Anyone can help him out?
So like you have your slope, so you just get rid of the 7,
What's the slope?
negative 2x over 3. Or negative 2 over 3 is your slope,
How do you know -2 over 3 is the slope?
because that's in y equals mx plus b, right? So
Well, this isn't y equals mx plus b yet.
yeah, so m is negative 2 over 3.
Well, you can divide 3 into each part to get -2 over 3x plus 7 over 3. And so here we see the m is in that location. So this is m for the first line.
Yeah, and then
Right.
like you just get rid of the 7 over 3, like pretend it doesn't exist. Put that as in like b, and then you can just use the point negative 2, 3. So you put 3 in for y, and then negative 2 in for b. Does that make sense?
3 for y, -2 for b. So So you're gonna say,
No, I lied. Put negative 2 in for x, not for b.
okay, so tell me what you would do
So-
after this.
3 equals negative 2 over 3 times negative 2 plus b.
Okay, why that equation? What did you think about it?
That's the slope-intercept form, right? So that can be
So you're thinking of y is equal to mx plus b, and you're plugging in 3 here. Why did you plug in minus 2 over 3 for?
that's the slope, and it's parallel, so it has to be the same slope.
Because it's parallel. We know it's the same slope. So the slope for this one must be the same as the slope for that one because it's parallel. Okay. And so now what do we have?
So you simplify 3 equals negative 4 over 3.
Not negative.
Or 4 over 3 plus b. And then you subtract 4 over 3. Whatever that is. 2
And what's that?
over 3.
No, 3.
What? Come again?
5 over 3?
5 over 3.
Okay. And so you would say what?
So your final equation would be y equals negative 2 over 3x plus 5 over 3.
The line. That is the slope-intercept form of the line. And so starting here. Alternatively, you could just use y minus y1 equals mx minus x1, and say y minus 3 is equal to minus 2/3 x minus plus 2, and you can solve for it from there. Minus 2/3 x minus 4/3 plus 3. That would be plus 5/3. But stopping here would be just as good. Right? I just did this to show you that it's actually the same. Any questions on this? I know he doesn't have any questions. He was getting frustrated with me. Did you see it? He's like, oh my God, this is that. But as you can see, I asked the question several times and people kept saying, oh, I'm not sure what to do at this point. I'm not sure what to do at this point. So I wasn't dragging it out for your benefit. I'm sure there are other people who didn't know what to do. So that's why I dragged it out. I also went through the situation of writing it in this form and then writing it in that form because I've seen a lot of students get to here and just don't know what to do because there's this huge line. What you do, if you divide both sides by 3 and you get something that looks like this, just divide the 3 to each part. The slope is going to be that part. Okay. Let's do finally E. Any other questions on this one? So because it was parallel, we know it had to be the same slope as the given line. So I just found the slope of this line by writing it in the slope intercept form. Then I just use the same slope to find the second line. Now this one is very similar. It's the same point, the same reference line, but now we're perpendicular. So how do you deal with that situation?
Use the negative reciprocal.
You use the
of
negative
slope.
reciprocal, right? So if D wasn't asked before E, you go through the same thing. start here, solve for y, you'd figure out the m, and then to find the perpendicular line, you'd flip that, take the negative sign. We saw that 2x plus 3y equals 7 has slope minus 2/3. This means slope for perpendicular line is positive 3/2. Flip it, change the sign. All right, that's the negative reciprocal. So this means y minus y1 equals mx minus x1. I would get y minus 3 equals m x minus plus 2. That's the equation of the line. And again, I'd stop there unless you were asked to use it the other way. But you could get to the other way by just solving for this. This is our first big example. So that's pretty much every scenario in which you need to find the equation of a line. I just killed in those two examples. So you can be told 2 points. You can have the information of 1 point and a slope. You can have the information that you just have a point and it's horizontal, or you have a point and it's vertical. Or you can have some reference line where we're saying, oh, the line over here is parallel to that guy or perpendicular to that guy. Pretty much every scenario in which you need to find the equation of a line at this point. So I should be able to throw any of these scenarios at you on a quiz or a test, and it should be no problem. Let's do some graphics for this. So let's go over the graphic. Should warn you here. So basically to graph anything that looks like x equals a constant, or y equals a constant, or y equals mx plus b, or y minus y1 equals m x minus x1. Okay. You need at most 2 points. The moment you plot more than 2 points, you are wasting time. In fact, I can tell you specifically that in either of the first 2 cases, you need 1 point. Whereas if you're in either of these cases, another situation you might find yourself in is or something like ax plus by equals c. And in these cases, 2 points. You will never need more than 2 points to sketch a line. Okay. Now, let's talk about that. Now, the horizontal and the vertical case, we're fine with, I assume. Okay. So, if you have x equals k, find the number k on the x-axis, draw a vertical line to it. If you have y equals k, find that number on the y-axis, draw a horizontal line to it. Okay, that deals with those cases. Now, in the other cases, I'm going to consider these as the easy cases that we don't have to go over. I guess if you have trouble with it, you can talk to me privately. But otherwise, the 2 points you should find are the x and y intercepts. Okay, and recall from last time, for the x-intercept, set y equals 0, solve for x. And for the y-intercept, set x equals 0, solve for y. Therefore, let's do some examples. Sketch the following. Okay, let's do 8. So, the process again is simply this. A and B are non-vertical, so I'm just going to find the intercepts. Notice that if I plug in x equals 0, I would get y equals 2. Pick a random point, call that 2. If I plug in y equals 0, I would get x equals 3. Pick a random point, call that 3. That is my line. Done. Takes a few seconds. So, notice that if x equals 0, your y would be 2, and that tells you that that point is on the line. And then if your y equals 0, you get that your x equals 3, which would mean that that point is on the line. Once you found those 2 points, you just draw a straight line through those 2 points. Just draw a curve with constant steepness passing through those 2 points. Nothing else to do. So a straight line should take you 0 time to graph. Close to 0. 5 seconds tops. B. Now here you could do the same thing, and I probably just always do the same thing. But it seems clear that that should be the y-intercept. Notice that if you plug in x equals 0, you get y equals 3 immediately. Pick a random point, call that 3. Now if I plug in y equals 0, move that 3 over, you're going to get another point here. Now this, you'll draw it through here. Now it'll often be the case that you need to find that point. Again, that would just be the x-intercept. So if I set y equals 0, bring this over, there will be minus 3, then multiply by minus 2, that would be 6. So that's the sketch of that one. So here, if x equals 0, y equals 3, you see that point. If y equals 0, x equals 6, you see that point. If you want to look at the situations y equals 1, and x equals minus 3, What does this one look like? Huh? This one, y equals 1?
Horizontal line.
Horizontal line
Horizontal line.
passing through y equals 1. So that's the picture here. This one is a vertical line passing through x equals -3. Pick a random point there. That's the line. So know that well. There will be situations where we have to draw a bunch of things on the same axes. Now, if some of those things happens to be lines, I expect you to take 0 time. Right? You should be able to say, oh, I want to find the region bounded by this line and this parabola. You're going to go here, that line, okay, that line. Here's the parabola. Find the point in between all of them, right? Ultimately, that's where we're going. Right? You want to be able to do things like that. But sometimes sketching a line in and of itself is going to be an important thing to figure out. And so that's how you do it. And so that ends 1.10. And we'll pretty much stop there. What's the last homework that I posted?
There's no homework up there now. The last one was 1.9.
I posted all the way up to 1.9?
Yeah.
Oh, good. Okay. All right. I'll make this due on Monday then. I will stop there.
Can you pick up homework after this lesson too? So just so we can take a look at it.
After what lesson?
Like, we did 1.10 today. Can you put what comes after this 1.11 on? Is that possible?
Oh, you mean post the homework? Okay. So next we're going into chapter 2. So 2.1 is the next thing we're going to cover. I'll make that due maybe the following Monday, but I'll make it live so you can see it. Stop there. Did you actually